Welcome back to our lesson practice. Today we got chapter 4, lesson 2, where the lesson summary for lesson 2 talks about our vertical asymptotes. So vertical asymptotes, the main thing to recognize here is that it happens when the function is undefined or when the x value makes the denominator 0. So as you look for this, so you can see in this situation, we have an asymptote. You can see it in the graph pretty easily, right? It's kind of like easy to see where the two pieces approach and don't cross. And so when we're going through this, we can see that it approaches this x value of 3. In the equation, we just are really looking for what makes the denominator 0. A couple things that the lesson summary says is it can be helpful to think about how the graph functions. So when x is just a bit larger than 3, which, right here somewhere, it's a very large positive number. When x is a bit smaller than 3, so somewhere down here, we get a very large negative number. So again, farther even somewhere off the graph as well. So number 1, select all the equations that could represent this graph. So in this graph here, I can see there's going to be a vertical asymptote over here. Again, we don't know exactly what number it is because we don't have any scale, but we know that it's got to be a positive number because it's to the right of the y-axis, which means that in this one here, it can't be A and it cannot be D, because when we're looking at this, we see if we plugged in a negative number, like this one would have an asymptote at -2, this would have an asymptote at -6. And so in this case, I need to have ones that would give me a positive asymptote, which would be B, C, or E. For problems 2 to 3, change the equation so that the graph has an asymptote at the dashed line. And this one here, the asymptote is going to be at the x value of -3. In this one here, I would need to change this to addition, because then when I plug in -3, it makes the denominator 0. So f of x really needs to be 2 over x plus 3. For number 3, I see that the asymptote is at +5. So that means that I would need to change this to be 1 over x minus 5. So that means that when I plug in 5, it makes the denominator 0. Problems 4 through 6, write a rational function where, for number 4, there's an asymptote at x equals -2. So in this one here, I could say f of x equals 1 over x plus 2. For number 5, it says x is less than 0 when the y value is greater than 0. And so in that case, when x is less than 0, for example, on my graph here, it's saying when I'm on this side, all these have to be negative. So I really have to have something that looks like this. Oh no, for when x values are less than 0, the y values have to be greater than 0. So I really have to have something up here. And so to do that, if I were to have, let's call this g of x. To do that, I need to flip kind of what we're used to. And so to flip something, I could say that it has a negative in the front because that reflects it vertically. Then for number 6, there are 2 positive vertical asymptotes. So having 2 asymptotes means that there's 2 different numbers that make the denominator 0. So for this one, let's call this h of x. And I could say 1 over x, 2 positive, so x minus 2 and x minus 3. That would give me an asymptote at +2 and an asymptote at +3. Number 7, which of the following has a vertical asymptote when x is a negative value? So in this one here, the number that would make the denominator 0 is 10. This one would be 5, and this one would be -1. So the only one that works on this is 3, which these questions are always a little bit confusing, but B would be my answer because 1 and 2 give me positive numbers for the asymptotes. Number 8, write an equation for a rational function that has a vertical asymptote for a negative value of x. So in that one, I need to make it x plus something. So f of x equals 1 over x plus 1, because then -1 would be my vertical asymptote. When x is 0, so that's just going to be g of x equals 1 over x. And then when x is equal to 4, so that one, h of x equals 1 over x minus 4, because then 4 would make the denominator 0. All right, on to our spiral review. 9 through 11, we have a function f of x, and we are trying to plug in some x values here. So f of 10, the way I would write that one, 1 over 10 minus 5 equals 1 over 5. F of 100 is 1 over 100 minus 5, which is just 1 over 95. I feel like these are cheating because of how kind of simple these are, but this is what they ask of us, so it must be important. 1000 minus 5, which is just 1 over 995. So just plugging in x values to get our y values. I think something to note here is that in this function here, as we get really large x values, we see the y values get really, really small. So kind of reintroduces our asymptotes idea, where as an x value gets larger, our y value gets smaller. That wraps up lesson 2. Pretty quick, pretty simple. Just got to make sure that we understand our vertical asymptotes and what that does to the denominator of our equations.